Okay, I suggest to start a little bit different way. When I see your file, it looks like you define the circle using that features like from the tool, right? Center with the radius, right? So you just choose B for the center and F for the radius, and this is the equation for that. I suggest not to use the tool buttons, right? Rather, you better start with two values. Let's say A and B or H and V, whatever, and they are for defining a circle equation. So roughly, your circle should be defined by x plus a and squared plus y plus b squared equals r. Okay, something like that. So right now, GeoGebra doesn't know what a, b, and r's are, right? So you have to decide a, b, r first. Then you could use this one as when you put that equation over there. The GeoGebra will assign name for that circle equation, right? Like a C or whatever. All you need is just place C as a text here, right? Then you can see the entire equation. You don't worry about plus minuses whatsoever, right? So the main task for you is how you define these A, B, R's, right? And A, B's I already sent an email, right? So A has some limitation, right? The ranges, right? And that's the kind of floor x coordinates corner one plus one or something like that, right? So you see how it's gonna work, right? So please work on that, right? And please let me know if you still have question. But please thinking about it, right? You need to kind of do this part, right? So, but I believe you already figured out that much, right? A should be between, let's say here, uh, if A is negative 4, then our circle, the center for the circle will place on this line. Then you cannot draw any circle which can be shown in this window, right? Because it's going to be off. So the A must be between negative 3 to 5, right? Giving us enough space and least radius one circle, right? So how can you get that 3 even when your students mess up the window dimension like that, right? Not dimension, but the ranges. So first of all, the corner 1 point will have around negative 4 point something for its x coordinates, right? So when you take the floor, then it's going to be negative 5. So that's why you have to add 2 there, right? Okay, so that's the minimum value for A. And maximum value is whatever the x coordinates of corner 2, you just take the floor, then which is 6 in this case, and minus 1 will be 5, right? So for the minimum value, you have to add up 2 from the floor value, but for the maximum value, you just take minus 1 from the floor value, right? Then A should be between negative 3 and 5 in this case, right? And even when you move around, it's going to be changed to negative 2 to 7, okay? And you just do the same thing for Y range, right? Ranges for Y. Okay, so when you take care of that, now you have to assign another condition for R, right? So let's just assume you have a point the A, B is kind of negative 2 comma 2. Okay, let's say that. Then at this moment, you don't have any choice. The radius must be 1, right? To see the entire circle here. So how can you figure out that radius? Now look at the situation. Which value of that coordinates of A will affect on the decision of radius? How you know the radius of the circle that you want to construct centered at that point is going to be 1 and no other choices. You still have like length 2 for that direction and length, I don't know, 7 or 8 to that direction and maybe 5 to this direction, but to here you have only 1, right? And that decide the radius, right? The restriction of radius. So all you need is just to calculate the distance from the x coordinates of corner 1 to the x coordinates of A, and x coordinates of corner 2 to x coordinates of A, right? And looking for which one is smaller, the minimum value, right? Of course, you have to take the floor of it, right? Because all you need the integer values, right? And same thing for y coordinates, right? Corner value, y coordinates of corner value of corner 4, and y coordinates of A, and y coordinates of corner 1 to y coordinates of A. So take the minimum of it, right? So all you need is just calculating that four values starting from A to D, each side, right? And take the floor of them and take the minimum among that four values, right? And that should be your possible maximum size for radius, right? Then what is going to be the minimum for R? It's just definitely 1, right? Not 0 whatsoever, right? So that in that way you can avoid to having 0 for the radius. So R is a random number, once again, same as A, right? B. R is a random number between 1 and the minimum values of those lengths, right? And I believe that is kind of enough hint for you, okay? And once again, please let me know if you have more questions, okay?